Hello, my dear students. Welcome back to the lecture. So once we have done the slab BBS, the last thing which is left out is about the chair reinforcement. So if you see it practically, this is the kind of a slab what we had done. We had the bottom mesh shorter and longer. Then we had provided the top mesh, isn't it? That is a top extra bar. And then the distribution bar was there. Now, if you ask me, how do you balance the top steel? You don't have an answer to that, right? So there is one bar which we didn't calculate and we need to understand that, which is called as a chair bar. So you can see a kind of arrangement done here. See, this is a kind of arrangement what we have done. See here, this kind of bar has come, isn't it? So this bar is called as a chair bar. Okay. So once your bottom mesh is done, we'll be placing the chair bar, and after that your top reinforcement will come. So you can see it here, isn't it? So 1, 2, 3, 4, 5, 6, 7, 8. So all these are the chair bar. Okay. Now first question is that why the chair bar has to be provided. So it's very simple. We know that if I ask you to plot the bending moment diagram of this is your beam column. I mean, this is your beam and a slab junction where you have a negative bending moment, then you have a positive bending moment, then again you get a negative bending moment, right? So you have a negative bending moment. That means you require a top steel. Now, if you don't give a top steel, what will happen? I mean, you are giving a top steel, but how do you give a top steel? You should give a top steel with the help of the chair bar. Now look at this guy. They have given a chair bar here and there is no chair bar kept here. So I'm making 1%. This guy is hardly 50 kg. The weight of this guy is 50 kg and he's standing on this. Now what has happened? Whatever top steel you have provided, everything has gone to the bottom, isn't it? Now imagine the same situation which will happen in your structure. So whenever you place the rebar, okay, and imagine that you're not given sufficient chairs, okay, then the moment the concrete falls on that, what will happen? The concrete will put a pressure, and whatever bar you had given at the top, they'll go down. The moment they go down, what will happen? Whenever the load comes on the structure, these were given to resist a negative bending moment. That means this bar should have been at the top, right? So now since the bar has gone to the bottom, there is no one at the top to take care of the negative bending moment. As a result of that, what will happen? Again, there will be a lot of cracks in your structure. So in this area, there will be cracks, right? So if I don't want that to happen, I need to give top steel, which already I have given. But in order to make sure that your top steel are properly functioning, you need to give the chair reinforcement. So got it? So that is why the chair reinforcement has to be given. Now you'll ask me one more question. Sir, we can see a chair bar here. We can see a chair bar here. We can see the chair bar here. But still, why this particular area has gone down? See, there is one rule. This chair bar, you have to provide for every 1 square meter, you have to provide one chair bar. So what do you understand by that? For example, let us consider I have a slab. I have a 4 meter by 5 meter slab. 4 meter is the breadth and 5 meter is the length of the slab. I'm taking one panel. So how many chairs you're supposed to give? First, we'll find the area. So 4 into 5 is 20. So it's 20 square meter. So now the clause is that for every 1 square meter, you have to provide one chair bar. That means for 20 square meter, I'll provide 20 numbers of chair. Finished. 20 numbers of chair. So you understood that? Maybe in this particular structure, here, these people are for every 1 square meter, they have to provide a chair. They didn't give that. That is why you can see this guy is standing here. So this portion has gone down. So that means they are not given proper chair. So they have to keep one more chair here. And only once you keep the proper chair, your top reinforcement will stay in the top position. And when the concrete falls on that, or maybe when the load comes, this top steel will serve its purpose for which it has been put for. Got it? This much understanding is clear? Fine. So once this understanding is clear, now the next question is how we'll find the cutting length of that. So for that, I've done a shape something like this. Before that, remember, one chair bar will be provided for every 1 square meter of the slab area. And what should be the diameter of the chair? This is a chair bar. I agree with that. But what is the diameter of this? So according to the code, or you just remember, this chair bar, whatever we are providing, no, it should be minimum 12 diameter bar. You cannot provide a chair bar less than 12 diameter. You cannot provide a chair bar of 8 mm or 10 mm. It has to be minimum 12 mm. It can be 16 and 20 also, doesn't matter. But minimum it has to be 12 mm. Okay. Now you can get a proper idea how the chair has been put, right? Fine. Now next question. Where do we provide the chair? It's not that only in the slab you provide. In the combined footing and even in the raft foundation also we provide a chair. Because just understand, wherever you are giving two meshes, that is bottom mesh and top mesh, in order to keep that in position, the bottom mesh and the top mesh, you are supposed to provide a chair. That's it. So even in the combined footing also we'll provide a chair because we have a bottom mesh and top mesh. Raft footing also we provide because we have a bottom mesh and we have top mesh. And in column beam, chair is not required. But in slab, chair is required. Okay, fine. Good. So once this is done, next we'll find the cutting length of that. Now, two things you need to understand, I mean, the values are, there are certain constant values which you need to understand. So this length, whatever you can see, this length, that is a top length, or you can practically, if you ask me, this length, it will be usually 600 mm. Okay, just remember the values. It will be usually 600 mm. So you'll ask me, sir, 600 from where did you take? No, I didn't take from anywhere. This is a general construction practice what we do. Few people keep it as 800 mm also. Few people keep this as 500 mm also. You can follow anything what is followed on your side. But usual practice what we do is we keep 600 mm, and that is fine. If you want to keep 500, keep 500. If you want to keep it 800, you can do that. No problem. Then this bottom leg, this is called as leg. Okay. This is also called as leg. So this one you can see, this one and this one. This we usually keep 300 mm. Again, if you ask from where it is taken, no, there is nothing written. That is a standard construction practice what we follow. If you don't want to keep 300, if you want to keep 500, keep 500. Doesn't matter. But 300 is sufficient because it has to just stay there. So that is why we give 300, which is usually a 1 feet or 12 inches. Got it? This much is clear. So these are constant value. So that means this portion is understood. It has to be 600 mm. This is also known to us. This is also known to us. What is unknown? This height. So this height we need to calculate. Okay, this height we are supposed to calculate. This height and this height. I mean, if you calculate one height, you'll get the other height also. So this two height we are supposed to calculate. So how to calculate, we'll try to understand. Now understand this green color, we usually call it as a head. Okay, you call this as a head, and this you call it as a leg. Okay, this is leg what we call, and this is called as head. Okay, and this will be a height. And this is a normal height what we have. Okay, great, fine. Now I'll explain it how this has to be calculated. This height is very simple. Okay, I'll just write it down. What is your slab thickness? Here it is given 150. So first take your slab thickness. From the slab thickness, deduct the cover of the slab from the top and the bottom. So slab cover is 20 mm. So minus 20, bottom cover, minus 20, top cover. Finish. Along with that, we're supposed to, what is that? Deduct the diameter of the rebar. Now tell me, see this rebar, okay? So where this rebar is resting, this rebar, if you want, I'll enlarge this portion. See now, where is this resting now? This is resting on the rebar, isn't it? That means this bottom shorter span and bottom longer span, whatever is the diameter, that we are supposed to deduct. Along with that, top also you can see, you have to deduct the two diameter of the bar. So totally 4 times you have to deduct the bar diameter. Okay, totally 4 times you have to deduct the, yeah, 4 times you're supposed to deduct the what is that, bar diameter. Okay, understood, right? So only then I'm going to get this particular height. So what I did, overall thickness, this is the thickness of your slab. This is the overall thickness. I mean, okay, 150 minus the bottom cover, minus the top cover. Okay, then minus shorter side diameter, longer side diameter, and also from top also you have to deduct the shorter side diameter and the longer side diameter. Then whatever is left out of that will be height of your chair. Understood? That's it. So if you understand that, we'll do it in the Excel sheet only. I think in the Excel sheet, I have done one mistake here. Yeah, this mistake is done. 150 minus bottom cover minus top cover. Yeah, then again it has to be minus. Fine. Now it will be okay. So first we'll do it manually. Okay. Your slab thickness is how much? 150 mm minus bottom cover is 20 minus 20 mm is your top cover minus bottom diameter. I'm considering my bottom shorter and longer and top shorter and top longer. All this diameter are 12 diameter bar. So minus 12 in the bottom shorter, minus 12 in the longer. Again from the top also minus 12 in the shorter, minus 12 in the longer. Now you do the calculation, how much you'll get, tell me. That will be a height. So 150 minus 20, minus 20, minus 12, minus 12, minus 12, minus 12. So it is 62 mm I got. So this height will be 62 mm, and you can see practically here, this is also 62 mm. This is also 62 mm. Done. So now you got all the value. You know this is 300. You know this is 62. You know this is 600. You know this is 62. You know this is 300. Add everything. We'll get the total cutting length that is required for the chair bar. So your total cutting length, I'll do it here. Okay. 300 plus 62 plus 600 plus 62 plus 300. How much I got? I got, yeah, I got 1324 mm is the total cutting length. But one thing you remember, whatever the formula I created, this is a formula created by me. It is not there in any code book. So when the formula is created by me, I need to do the bend deduction. Usually we need to do. If you don't want to do also, no problem. You can take 1324 is the total cutting length. But if you're supposed to do the bend deduction, so we have 190-degree bend here. There's another 90-degree bend here. There's another 90-degree bend here. And there's another 90-degree bend here. So four 90-degree bend we have. 190 degree bend is 2D deduction. So 4 twos are 8. So 8D deduction I'm supposed to do. I'll do that. This answer minus 8 into D, diameter of the bar. This is a 12 diameter bar. I multiply this by 12. How much I'm getting? 1228. Same answer, I got it here. Now again, it's totally up to you what you practice on your side and what kind of projects you're working on. Okay. So if you want to do the bend deduction, the answer will be 1228, considering 90, 90, 94 times 90-degree bend. If you're not doing a bend deduction, no problem. Your answer will be 1324. This answer will be 1324 because it is 300 plus 62 plus 600 plus 62 plus 300 comes out to be 1324. Clear? You understood how it has to be done? Right. That's how it is. That is how the chair bar BBS has to be done. Now, simple. I already created the Excel sheet. Simply, if I change the thickness to 200, my answer will be ready according to that. See, my answer is also ready. Suppose if my, slab thickness is, let us say, 250 mm. Okay, finish. So my BBS is ready. Okay. So you can create a shape something like this and keep. And based on that, you can try to do the calculation. Okay, I'll keep 150. And if your bar diameter is different, based on that, try to do it. Okay. Now the main intention is to find the cutting length, how many number of bar is required and all. So those things I'll teach you in the next lecture. That is for the project what we have worked out on one project, isn't it? This project we have worked on. Okay. So for this complete slab, we got 11,418 kg of a steel was required, isn't it? So, but we didn't calculate the chair bar for the entire first floor. How many chair bar is required? We'll calculate that, and what is the steel required and all. We'll see that in the next lecture. Okay. So just try to understand the concept, how it has been done, how the BBS for the chair bar has to be done. So we'll see you back in the next lecture. Thank you.